Okay, with this next problem, we're going to be, again, doing our rainbows and scoops. Okay, so 4m times 3m. I'm going to multiply those coefficients out front. 4 times 3 is 12. M times m gives me m squared. And then I'm going to say 4m times 8 is plus 32m. Negative 7 times 3 is minus 21m. And negative 7 times 8 is negative 56. I'm going to have to make sure I separate. Okay, so I can collect my like terms here in the center. So I'm going to have 12m squared. 32 minus 21 is going to give me 11. And, I'm sorry, I can't write very neatly here, sorry. It's going to be positive 11m. And then minus the 56. Okay. Moving on to the next one. Again, rainbows and scoops. 5x times 3x is going to be 15x squared. 5x times 4 is going to be plus 20x. And then doing our scoops here, we have 2 times 3x is going to give us 6x. And then 2 times 4 is going to give us 8. And again, we can collect our middle terms here because they're like terms. So we've got 15x squared plus 26x plus 8. Okay, so this last one, 5x times 3x is going to give us 15x squared. 5x times negative 4 is going to give us minus 20x. Okay, and then when we have 2 times, I guess I didn't draw my rainbows and scoops if that helps us stay in touch here. So 2 times 3x is going to give us positive 6x, and 2 times negative 4 is going to give us negative 8. Again, we're going to collect our middle terms, but we've got 15x squared, and this is going to be minus 14x minus 8. Now, these last two I want you to take a look at. They looked pretty darn similar. We had 5x plus 2, and in this first case we had multiplying it by 3x plus 4, and this next time we're saying 3x minus 4. They're very similar except for that sign right there, that last sign. But look how that changes our total outcome here. This begins and ends the same way. My 8 really needs to look like an 8, but the middle term has totally changed, and that last sign has changed. So I just want you to be aware, you've got a lot of stuff going on with your signage here, and so you're really pulling together a lot of skills here. Your addition, subtraction, multiplication facts, your accuracy with that. You're dealing with, you're switching from multiplication of whole numbers to your exponent rules, and then you're switching to collecting like terms. You're just pulling an awful lot of core skills together to carry out this strategy. Okay? Now, the way that this is very often thrown at you on the high set is they a lot of times don't give you, hey, here's 2 binomials, multiply them together. They will give you some situation like this where you are to write an expression that would represent, hey, perhaps the area of the different rectangles or squares. In this case, we've got a square, and then write an expression that writes the expression that represents the perimeter, and then solve those or simplify those. And so they're actually going to test you on your polynomial skills as well as what you know about geometry. Okay, and we probably haven't had a whole lot of geometry, but this is one place that they will really test you on it. But in geometry, if you were finding the perimeter of a square, the perimeter is you're adding up the number of sides. You're adding up the distance around the sides. Well, there's all 4 sides are equal to each other, and each side is equal to this 3x plus 4. So you could take perimeter is equal to 4 times the number of sides, or the measure for the sides. So perimeter would be equal to 4 times this expression, 3x plus 4. And then I could go ahead and distribute that through. So now you're using your algebra skills with polynomials. So that would give you 12x plus 16. So the perimeter would be equal to that expression there. So they've tested you in 2 skills there. What do you know about calculating perimeter, and can you apply that to when your side is given as an algebraic expression? Now if I'm finding area, the area of a square is that side squared, because you're taking the length of the base times the height. The base and the height are equal to each other, so it's that side times itself. So I could go ahead and put in this expression for side. So this would be 3x plus 4 squared. Now this is kind of tricky here, because you want to look at this and say, oh, this is where I distribute that back. But it's not. What I want you to recognize is this square out here means this whole expression times itself. So you have to write that out as 3x plus 4 times 3x plus 4. And then you recognize, I got to do rainbows and scoops. So 3x times 3x is going to give you 9x squared. 3x times 4 is going to give you plus 12x. 4 times 3x is plus 12x. And 4 times 4 is plus 16. You're going to collect your middle terms here. You're going to have 9x squared plus 24x plus 16. And that would be your area. You're asking yourself, well, okay, I know somewhere along here we did this where we were distributing back, didn't we? And I want to show you what you might be confusing it with so you can kind of keep it straight. Keep in mind, this inside here is a binomial. You have 2 different terms separated by a positive sign in here, and you need to kind of recognize that. Because I think you might confuse that with something like 3x squared y. That whole thing may be raised to the 4th power. Here you've got 3 different terms in here. There's no plus or minuses, 3 different variables or components, but it's a single term. There's no plus or minuses in here. So you have to take each of these items and raise it to the 4th power. That's where you're going to be distributing this back. So 3 to the 4th power would be, let's just write 3 to the 4th power for right now, and then 3 or x squared raised to the 4th power, that's where you're going to be multiplying that exponent. That would be x to the 8th, and then y to the 4th power would be y to the 4th power. If you wanted to, you could look at this and say 3 times 3 times 3 times 3. 3 times 3 is 9, 3 times 3 is 9, so 9 times 9 would be 81. So I could simplify that even further and come up with this. This isn't really the main crux of this lesson here, but I want to point out how this looks different. There's no plus or minuses in here, but you've got this raised to a power. That's where you distribute it back. Here, there's this plus sign in here. So that's telling you that this is a binomial. You're saying this whole thing in here times itself. So you could write it out twice, and that's a different scenario. I could have done that over here, written out everything inside here 4 times, but then I'd see that I just could be collecting it. I just want you to see the difference there. Okay, and then we want to move on to one more example that blends the geometry, and that would be this scenario here where you've got a rectangle. You've got the width and the length are different measures. And so again, I'm going to ask you to come up with the expression that would represent the perimeter. So you need to recognize that the perimeter in a rectangle, you've got 2 widths. 2 widths, this one here and this one here, and then we have 2 lengths, this one here and this one here. So the formula for finding the perimeter is 2 times the width plus 2 times the length. And so we need to recognize that this is my width. I can plug this in for the width here. So I'd have 2 times 4x minus 1 plus 2 times my length is this right here. So that would be 7x plus 2. Hopefully you can see that okay. And then I can distribute. So that would give me 8x minus 2, distribute again, and I would have plus 14x plus 4. I can collect like terms, which is going to give me 22x. These 2 here are like terms, and then these 2 are like terms. Collect those, and that would be plus 2. So my perimeter would be equal to this expression. When I go to find the area, what I'm doing there is I'm saying my area, the length times the width, would be 4x minus 1 times 7x plus 2. So I could go ahead and recognize that I'm going to have to do my rainbows and scoops again. So 4x times 7x is going to give me 28x squared. 4x times 2 is going to give me plus 8x. Negative 1 times 7x is going to be minus 7x. Negative 1 times 2 is going to be minus 2. Collect my middle terms here. So I'd end up with 28x squared. This would be minus 1x, or x, minus 2 would be my area. So I want you to take a look at that before we go on to some weird scenarios that occur. Actually, this number right here should be positive. Sorry about that. Okay, and then we're going to move on to some weird scenarios that you might come across. And this was, again, that situation that we came across with our square, the side of the square being times itself. This I want you to recognize is saying everything inside here times itself twice. So x plus 3 times x plus 3. Distribute, 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 distribute. So we're going to have x squared plus 3x plus 3x plus 9. Our middle terms collect, so we're going to have x squared plus 6x plus 9. Okay, how does this play out when we have a negative in here? But again, it's this kind of the same scenario. That expression times itself twice. And you have to do the rainbows and scoops. So x times x is x squared. X times negative 5 is minus 5x. Negative 5 times x is minus 5x. Negative 5 times negative 5, that's a negative times a negative. That's going to come out to be positive 25. So when we collect our middle terms, we end up with 10, or x squared minus 10x plus 25. So it's not anything that you need to be, pull into play, but I want you to kind of recognize that when you have a binomial in here times itself, in other words, that binomial squared, this last term is that last term there squared. 3 squared is 9. And this middle term is the double of that term times that number out front. That same thing happened here. Negative 5 squared is positive 25. The middle term here is that number double times the x in here. So that's kind of interesting. That kind of plays out. Again, here we probably won't have to do it a third time, but we will. So 2x times 2x is going to give us 4x squared. 2x times 5 is going to be plus 10x. 5 times 2 is 10x. 5 times 5 is plus 25. So 4x squared comes down. These two collect to be 20x. And the last term is 25. So how did that impact things? What we see is that this last term is that term squared. The first term is our first term squared. And the middle term is the product of both of these doubled. 5 times 2x is 10. Doubled would give you 20x. So it's just kind of a unique pattern. And each of those are a binomial. We call that a binomial squared. Let's see what happens on these next two. I just don't want you to freak out when this occurs. We've got two binomials that we're multiplying. They look like they're almost exactly the same. They only differ by the sign. Let's see what happens when I do my rainbows and scoops. So d times d is d squared. D times negative 5 is minus 5d. 5 times d is plus 5d. And then 5 times negative 5 is minus 25. My middle terms collect, and goodness, what is this all about? Negative 5 and positive 5, they cancel each other out. So I'm just left with my last term. So when I have different signs here, the middle terms are going to cancel each other out. And we call that the difference of two squares. This is a perfect square, this is a perfect square, and we're subtracting them. Let's see if it happens over here. So 2x times 2x is 4x squared. 2x times 3 is positive 6x. Negative 3 times 2x is minus 6x. And negative 3 times positive 3 is negative 9. Same thing happens. The middle terms are going to cancel each other out. And I'm left with 4x squared minus 9. and that first term is the first term squared. That last term is that last term squared. And they're subtracted. So it's just kind of a unique pattern. I just wanted to show it to you. Okay, as far as, up until this point, we've looked at polynomials, what they are. We looked at adding and subtracting polynomials, which was just a matter of collecting like terms. We looked at multiplying, depending upon if we had 1 term, 2 term, 3 terms, different scenarios occurred. But the rainbows and scoops is something we really need to be aware of when we're multiplying 2 different binomials. The last thing that we really should take a look at is the division of polynomials, and probably the easiest thing to make sure we have down is when we take a polynomial and divide by a monomial. In other words, divide by a single term. We could divide by binomials and trinomials, but it gets to be very involved, and I would just like you to make sure that you have this part down for sure. So we've got, each of these are separate problems. So it's just a matter of simplifying your exponent using your rules here in whole number reduction. Here I can remember that I need to subtract my exponents, so that would be 20x. When I say 3 minus 2, that'd be to the first power, so that just simplified to 20x, and that's all we have to deal with. When I'm looking at this one, I am simplifying both the whole number out front and simplifying the exponent rule. So 4 goes into negative 28, negative 7 times, and then here I'm simplifying, subtracting my exponents, so I'd have m to the 4th. Here, you're just kind of doing that same thing 3 times. So 2 goes into 56, that's going to be negative 28. P to the 5th, divide by p to the 2nd. You're subtracting those exponents, so that's going to be to the 3rd power. Q to the 7th minus to the 5th would be q squared. And over here, I guess I want to use this space down here to rewrite it, that I can break that into both terms divide by 3x. So 9x to the 5th divide by 3x minus 6x to the 4th divided by 3x. So that would simplify to 3 goes into 9 3 times. That's to the first power, so that'd be x to the 4th. 3 goes into 6 2 times. And then that's to the first power, so I'd subtract and I would have x to the 3rd power. So I could do this would be the solution for this one. So I could do that same thing here. I could say 8x to the 7th divide by 4x to the 3rd minus 32x to the 5th divide by 4x to the 3rd. 4 goes into 8 2 times, and then I'm subtracting these exponents, so that would be x to the 4th minus 4 goes into 32 8 times, and then I'm subtracting the 5 minus the 3 would be x squared. So that'd be the solution to this one. And so I think that's as far as we really need to go with division of polynomials.